All right, today we're skipping to chapter 8.5 and learning about partial fraction decomposition. So what we want to be able to do is take a rational function and maybe where we would have normally done long division or something like that to split it into terms we can integrate. We want to be able just to get right down to splitting it into smaller rational functions that we can also integrate pretty easily. So we already know how to do the reverse of this. So if I give you two rational expressions, hopefully you can form a common denominator. So x plus 2 times x plus 3, and multiply each fraction accordingly to get the common denominator. So this would be like x plus 3 minus x minus 2. X minus x cancels. 3 minus 2 just gives me 1. Okay, so the idea here is we already know how to add fractions, but what if I give you 1 over x plus 2 times x plus 3, and I didn't give you the two fractions? Can you figure out what were the two fractions that we added together? So the new process does the reverse. You're given this, or something like this, and then you'd have to figure out it's equal to what plus what. You would know this much, but the question is, what is the top and the bottom? What are the tops? What are the numerators of those two fractions? All right, so there are some sort of steps you can check and look at. Make sure that the degree of the numerator is less than the degree of the denominator. If it's not, you still need to do long division. So basically make sure that you have a bottom heavy, that's our informal pre-calc term, a bottom heavy rational function before starting. Factor the denominator completely so you know what your denominators are going to be. Rewrite the original problem as, because our unknowns are here, a over one denominator plus b over the other denominator. And the denominators, again, are your factors that you just did. And then I'll show you how to solve for the constants. Once you solve for the constants, then you'll be able to integrate each of those. All right. So let's start with this one. This is bottom heavy, so check on that. And we can factor this into x minus 3, x plus 2, right? And the next thing is to rewrite the original problem. So let's remove the integrand from the integral for a second and say x minus 1 over x minus 3 times x plus 2. It's got to be the sum of some fraction that has x minus 3 in its denominator. We'll say a. A is the top variable for that, plus something b over x plus 2, right? Because I would get a common denominator for those two, and I would somehow end up with this. So then the next thing you can do is multiply by the least common denominator, right? So multiply by the x minus 3, x plus 2. That's going to give us x minus 1 equals a times x plus 2 plus b times x minus 3. That's just what I multiplied by the denominator. Okay, and then we want to be able to solve for a and b. So we want to pick some values of x that will help us solve for a and b. So you want to pick values of x that make either the a term disappear or the b term disappear. So let's start with, let x equal negative 2. If that's the case, then the equation becomes negative 2 minus 1, negative 3, equals 0 times a, plus, I'm not going to write 0 times a, plus b times negative 2 minus 3, negative 5. And so that allows me to solve for b. B is positive 3/5. All right, and then you can go back and do the same thing. You don't want to plug in b and then solve because that could get messy, but you could say, okay, start over. Let's let x equal 3. When x equals 3, what happens? What does that tell us that a is? So 3 minus 1 is 2. That would equal a times 3 plus 2, 5, plus 0, right? So then a is 2/5. And so now I have the coefficients. They're fractions, which is not great, but they're fractions, and we can work with those for our integral. So here's what we have now. Now we have that this integral has been split up into a is 2/5 over, a was over, go back to the original. x minus 3 dx, plus b was 3/5 over what was b originally over x plus 2 dx. And it's ugly to have a fraction in a numerator, so let's pull those out in front. 2/5 times the integral of 1 over x minus 3 dx plus 3/5 times the integral of 1 over x plus 2 dx. How do we integrate these? Remember, these are little u subs that are nice and cooperative. U is x minus 3, du is just dx, u is x plus 2, du is just dx. Remember, we have to worry about like if it's 3 minus x or if it's 2x plus 2 or something, we'd have a little adjustment to make. But these are easy to integrate. If these are both just 1 over u, the integral of 1 over u is natural log of u. So this becomes 2/5 times the natural log of the absolute value of x minus 3 plus 3/5 times the natural log of the absolute value of x plus 2. And they're indefinite integrals, so plus c. So for these partial fraction decomposition problems, you basically are always ending up with natural log antiderivatives. It's just a question of what are the coefficients that are out in front, and do we have to make any little minor adjustments? All right, so let's do this again for example 2. So off to the side, let's work on this first. This is 1 over factor this x plus 3x plus 2. That's equal to some sort of a over x plus 3 plus some sort of b over x plus 2. Order does not matter here. If you've reversed these, we're going to get the same coefficients in the end. Multiply by the least common denominator. That leaves us with 1 equals a times x plus 2 plus b times x plus 3. In one scenario, we can say x is going to equal -2. That's going to make this 1 equals 0 plus b times 1. So b is just 1. And then let's let x equal -3. In that scenario, the equation will be 1 equals a times -1 plus 0. So a is -1. And then just be careful about putting these back into the integral because you have to look back here. A went over x plus 3. So it's -1 over x plus 3 dx plus the integral of 1 over x plus 2 dx. And let's pull the negative out in front. I might rearrange also. It doesn't matter, but I don't know. I like to have the subtraction in the middle. Again, I'm not going to write the u sub. U would be x plus 2, so du would be dx. There's no extra, but you do need to be on the lookout for that. But in this problem, there's no extra little adjustments to make to satisfy du. So this is just the natural log of x plus 2 minus the natural log of x plus 3. Oops. Plus c. And you do need to note that if these are multiple choice problems, they might condense using log properties. So if you're looking for this answer and you don't see it, it could be that they've made it, because we're subtracting logarithms, it could be that they've made it the natural log of x plus 2 divided by x plus 3. So you do need to remember that from pre-calc. If we're subtracting logarithms, we're dividing the results inside of the natural log. Okay, on to the next page. There is a shortcut. So you can always write this out. This is not that cumbersome, but there's sort of a shorthand way, sort of like long division versus synthetic division. And this always works, so that's kind of nice. All right, so we call this the cover-up method because you're literally going to cover up something and then work on the rest of it. So here's how this works. You set up the integral ahead of time. I know that x squared minus 4 factors to x plus 2, x minus 2. So one of these denominators will be x plus 2, and I'm going to leave space for a constant out in front. One of these denominators will be x minus 2. And so the question is just what's on top here. Or actually, I could even put a 1 here and a 1 here. And then the question is really like, what is the coefficient? What is A going to be? What is B going to be? And I'll just put them out there to start. All right, so how do we do this? To figure out this first one, you kind of plug in x equals -2 into this expression here, but you cover the x plus 2. So what does that mean? It means cover up x plus 2, and you're just plugging into 3x plus 2 over x minus 2. All right, so covering that up means I'm not going to be plugging -2 into that. So this becomes, if I plug in -2, I get -6 plus 2, so -4, over -2 minus 2, -4. So I get 1. So that coefficient is just a 1 in front. And then for this second integral, I'm going to plug in x equals 2. I'm going to cover x minus 2. So if I cover x minus 2, I'm plugging into 3x plus 2 over just x plus 2. If you plug 2 into that, you get 6 plus 2 is 8 over 2 plus 2 is 4. That one comes out to 2. So I write plus 2. So the reason that works is because you basically the cover up thing and the plug in thing, it's the same idea as what we were doing here. Pick a value that makes one of these terms go away. And because that term went away, that's sort of like the cover up method, right? Like to solve for b became 1 over x plus 3. And you just plugged your -2 into that. You covered up the x plus 2 and plugged in -2. And to find a, I covered up the x plus 3 and I plugged in -3 and I got -1. So it's just a shorthand version of this. So use whatever one you like. From there, the calculus is the easy part. It's just, all right, integral of 1 over x plus 2, natural log of the absolute value of x plus 2, plus 2 times the natural log of the absolute value of x minus 2, plus c. Again, look out for condensing things like 2, a number in front of a natural log can become an exponent. This could be the natural log of x plus 2, absolute value, I guess, x plus 2 times x minus 2, and the x minus 2 could be squared, plus c. You don't have to do the condensing on your own if this is a free response answer, but you might need to search for it if you're looking for multiple choice. All right, same thing here. All of these are bottom heavy, by the way. I should mention that. So this factors into x plus 4, x plus 2. Let's get the integral set up. So leave some space for a constant out in front. We're going to have 1 over x plus 4 dx. Leave a little bit of space. And then 1 over x plus 2 dx. So I'm plugging into this one, x equals -4. I'm covering x plus 4. Cover that. And you're plugging into 2x plus 5 over x plus 2. So plug -4 into that, you get -8 plus 5, which is -3. -4 plus 2 is -2. So I get positive 3 over 2. For this one, I'm going to be plugging in x equals -2. That means I'm going to have to cover the x plus 2, and I'll be left with 2x plus 5 over x plus 4. So plug -2 into that. -4 plus 5 is 1. -2 plus 4 is 2. So we get plus 1/2. And then we calculus, and we get 3/2 times natural log of absolute value x plus 4 plus 1/2 natural log of absolute value x plus 2. That one's uglier to condense. These could still be exponents if we wanted. I'm not going to worry about that. All right, number 5. Remember, we need to, if this is top heavy, we can't just go splitting into partial fraction decomposition. So we need to divide first to see what we're working with here. So let's do the long division just off to the side here. That will get us to a place where we have a fraction that's bottom heavy at some point, because that will be our remainder. All right, so we multiply x squared by 2x to get 2x cubed. X squared minus 2x squared is -x squared. Negative 7 plus 4 is minus 3x plus 7. We multiply x squared by minus 1 to get negative x squared minus x plus 2. Subtract all of that. Bring this over here. So that gives me negative 3 plus 1 is negative 2x. 7 minus 2 is plus 5. That becomes the remainder. Should be the x on that. So now the problem is the integral of 2x minus 1 plus negative 2x plus 5 over x squared plus x minus 2. All of that gets a dx. Now, the first two terms are easy to integrate. 2x becomes 2x squared over 2, which is just x squared. Minus 1 becomes minus x. And then our integral here, this last term, we need to set up. We've got, let's leave some space actually. We've got 1 over, how does that factor? X plus 2. And then there's also going to be an integral of 1 over x minus 1. And then we're going to use the cover-up method again just on this part to figure out what these constants are. So first what I do is plug in negative 2, plug it into negative 2x plus 5, and you're covering up the x plus 2, so it's going to be over x minus 1. That becomes positive 4 plus 5, which is 9. Negative 2 minus 1 is negative 3. So that becomes minus 3 in front of that integral. And this one we're going to plug in x equals 1. We're plugging it into negative 2x plus 5 over, cover up the x minus 1, so you're plugging it into x plus 2. If you put in 1, you get negative 2 plus 5 is 3, over 1 plus 2 is 3, so plus 1. So final answer here is x squared minus x minus 3 natural log of the absolute value of x plus 2 plus the natural log of the absolute value of x minus 1 plus c. All right, and then I've mentioned this before, but again, multiple choice problems, see how these are condensed, and they might try to, they're just slightly different, the order or whether you are dividing or multiplying in here. So I haven't seen anything too terrible, but it's just about being careful. So this is going to factor into x minus 4 and x minus 2. If you plug in 4 and cover up 4, you get 1/2. If you plug in 2 and cover up x minus 2, you get minus 1/2. So it's going to be 1/2 natural log of this minus 1/2 natural log of this. Subtraction means we divide, and we divide in this order. So it looks like we ought to have this answer. All right, example 7. So this is bottom heavy, but just because we have a rational, just because we have something rational doesn't mean we can always do partial fraction decomposition. I can't factor this denominator because it's x cubed. So don't forget about all the other methods. That's what chapter 8 is all about. Like remember, or chapter 8 is like remember everything basically. So, okay, I can't do partial fraction, but I can do u sub. U is equal to x cubed plus 3x minus 4. Du dx is equal to 3x squared plus 3, which is 3 times x squared plus 1. So I have x squared plus 1. I just need to multiply a 3 in, balance it with a 1/3. And I always like to rewrite the integral in terms of u. So this leaves me with 1/3. 3x squared plus 1 times dx is du. And I have 1 over u, which is that entire expression. So this is 1/3 times the natural log of the absolute value of u, which is x cubed plus 3x minus 4 plus c. All right. And then what about trig? Could we start working on any sort of identities or anything like that? I don't see anything too obvious. This is cotangent. But if I were to FOIL this together, that's not going to give me like a nice identity. But you are able to still look at this as like kind of using a cover up method. So you can kind of do this. Like, we don't want to put in our trig values right off the bat because that's going to be harder. But what about this? We have, let's see, u is sine x, du dx is cosine x, right? So that takes care of that and that. And then what is this? Well, if u is sine x, then u minus 1 is sine x minus 1. So we can rewrite the problem in terms of u. We have 1 over u times u minus 1. We do have du. And then this is something I can use partial fractions with. It's already factored for me, so I can say that's going to be 1 over u du. And this one's going to be 1 over u minus 1 du. And then we're not worried about the sines and cosines yet. We're just saying, all right, this would be u equals 0, and you're plugging into just 1 over u minus 1. If you plug 0 into that, you get minus 1. And then here u would be 1. Cover up u minus 1. You're plugging into 1 over u. 1 over 1 is 1. Okay, so then I get negative natural log of absolute value of u. Let's plug sine x back into that. Plus natural log of u minus 1. So sine x minus 1 plus c. Kind of cool, right? And then that could be condensed too if we needed to. All right, that's it for this video. The homework today should be number 4, I believe. Come see me in office hours if you need help.